Hi all. This is the fourth introduction to the simulation in principles of electric circuits. Let's discuss how to use multisim to do the time domain simulation. We said in lecture 47 that the dynamic circuit needs two necessary conditions to start its transient process. One is that it needs energy storage elements, so we need to firstly introduce how to add energy storage elements to circuits. First, click here. There are capacitors and inductors. You can select them with different parameter values. For example, we have put a capacitor and an inductor. We put another inductor. The connecting way is exactly the same as usual. After that, the condition for a transient process is switching. The switching is most often realized by switches. The switches are also in BASIC. Here is a switch. There are many types of switches. Here are some often used ones. This is the SPST switch. It's controlled by the space key. You can see that the state of the switch is changed after we press a space key. Of course, we can change the triggering key and adjust the on-state resistance and off-state resistance. Apart from that, we'll have current-controlled switch. That is to say, when the current flowing through terminals 3 and 4 is larger than some value, terminal 1 and 2 is connected. Here is the on-state resistance. When the current is lower than that value, terminal 1 and 2 is opened. Here is the off-state resistance. Similarly, we have voltage-controlled SPST switches, which we don't repeat the above introduction. Besides SPST switches, there are SPDT switches. This is a key-controlled SPDT switch. The control key is space. Please see. Apart from them, we discussed in lecture 50 that if the period of a square wave is far longer than the time constant of the circuits, or in another way, far longer than the transient process, we can use square wave as a way of representing power source and switch. There is another very important switch, that is, time-delayed switch. In order to clarify it, we made such a simple circuit. It is constituted by a voltage source and a resistor. In order to see all the terminal numbers of the switch, we need to right-click the mouse on the screen, select Properties, and select Footprint Pin Names. The default option is not selected. Please see that this is without number. After selection, press OK. We can see the numbers. What is the definition of the time-delayed SPDT switch? At first, terminal 1 is connected with 2. After 0.5 millisecond, terminal 2 is connected with 3. After 2 milliseconds, go back to the connection between 1 and 2. To verify the conclusion, let's do the simulation. In the time domain simulation for dynamic circuits, we have two ways. You have already seen the first way in lecture 48, that is to use a scope. Here, we'd like to introduce another way, that is with menu. Click Simulate Analysis, Transient Analysis. Now we want to see the time change of node 2. We need to set the start time as 0 and the end time as 5 milliseconds. Others are kept default values. In the output, we set node 2 voltage, that is the voltage on the resistor. Press Simulate. We can use a cursor. Please check. At 0.5 millisecond, the resistor gains the voltage. That is, the connection changed from R1 to R3 at 0.5 milliseconds. At 2 milliseconds, the resistor has no voltage. That is, it recovers back to the connection of R1. In this way, we verify the function of the time delay switch. There's another type of switch that is a voltage-controlled SPDT switch. To verify the function of such a voltage-controlled SPDT switch, we set the controlling terminal voltage as a square wave changing from 0 to 3 volts. The power source of the circuit is a sine wave. Let's open the scope and click Run. Please see. In the period with value in the square wave, sine signal can power the resistor, which means terminal 1 is connected with 3. In the period with 0 value in the square wave, the resistor has no voltage, which means terminal 1 is connected to 2. We need to make note that in this voltage-controlled SPDT switch, there is a threshold for the opening voltage. In multisim, this value is not accurate. Please check that if the voltage is accurate, the input signal needs to reach 5 volts to open the switch, but now 3 volts can open it. To verify it, we can set the parameters as 50 and do the simulation again. See? Now 3 volts will never connect terminal 1 and 3. After introducing all elements, let's do a simulation. Okay, now we use a specific dynamic circuit to demonstrate the time domain simulation. The circuit contains a voltage source, a resistor, and a capacitor. The switch is a time-delayed SPDT switch. At 0, terminal 1 is connected to 2, and after 2 milliseconds, terminal 2 is connected to 3. After 1 second, terminal 1 is connected back to 2. We purposely set a very long time, 1 second, in order to ensure that this time is over, transient is over. To verify that, please check that the time constant is 1 milli, so it's long enough. We press Simulate Analysis, Transient Analysis. Here we start the simulation at 0 and end it at 10 milliseconds. Because the time constant of the circuit is 1 millisecond, the 10 milli is enough. We set the voltage of the node 3 as the output. Please see, the circuit is on at 2 milliseconds. And then the capacitor voltage rises from 0 to 12 volts in this way. Sometimes the element is with initial value. Then what we can do? One method is to use another time-delayed SPDT switch to power the capacitor. There is another simpler way. We can set the initial voltage value here. For example, we can set it as 5 volts. Click OK. Then we need some special setup in doing the simulation. We need to select the user-defined here as the initial condition. Let's do the simulation again. You can see that from 0 to 2 milliseconds, there are 5 volts defined by us. Here the capacitor can also embody the initial value of 5 volts. After 2 milliseconds, the capacitor voltage is charged to 12 gradually. Okay, here we finish the introduction to the simulation in time domain for dynamic circuits.